So here's our video for the discriminant. So discriminant is, so first question is determine the number of solutions of the quadratic globe by finding the discriminant. So discriminant is just what's under the quadratic. That's b squared minus 4ac. So the first thing you have to do always, so this is 3a squared minus 6a plus 2 equals negative 7. Is you make sure that your quadratic is set equal to 0. Whether it's the quadratic formula or this right here, you always have to set it equal to 0. Then you determine what a is, what b is, and what c is. In this case, a is 3. So a is equal to 3, b is equal to negative 6, and c is equal to 9. So I put that in. So this is going to be negative 6, always put this in parentheses, squared minus 4 times 3 times 9. So that's going to be 36 minus 4 times 3 times 9. So this is going to be 36 minus 108. And 36 minus 108 is going to be negative 72. When you have a negative 72 here, well, that tells you something, okay? That's when your discriminant is less than 0. That means that you have two imaginary solutions. Okay, you have two imaginary solutions and no real solutions. Number 2, determine the number of solutions by finding the discriminant, showing all work. So for this one right here, you're going to do the same thing. Make sure you set it equal to 0. This is 3n squared is equal to 6n plus 3. It doesn't matter which way you do it. I'll do it both ways. You could have added 3n squared. So this would have been 0 is equal to 3n squared plus 6n plus 3, and a in this case would have been 3, b would be 6, and c would be 3. So this would be, it's b squared, so it would be 6 squared minus 4 times 3 times 3, so that would be 36 minus, and then 4 times 3 times 3 is 36. This would be 0. If we did it the other way, so you had your negative 3n squared is equal to 6n plus 3. If I subtract 6n, subtract 6n, so this is negative 3n squared minus 6n is equal to positive 3. I subtract 3, negative 3n squared minus 6n minus 3 is equal to 0. For this one here, in this case, a would be negative 3, b would be negative 6, and c would be negative 3. And I do the same thing. It would be b squared, make sure you put in parentheses, b squared minus 4 times a times c. This would be positive 36 again, minus 36, which would still be 0. And when you have 0, you're going to have one real solution. And just to remind you, if we were graphing this, if we were looking at a graph, this graph would touch the axis at one point. I'm going to go back to the previous problem really quickly. Number 1, if we were graphing this one and it was imaginary solutions, my graph would not be touching the x-axis. It could be going that way, it could be going that way. Number 3, same thing. I'm just going to do this one way. I just showed you that one instance where it doesn't matter what you do. I'll do it both. So 4p plus 2p squared. I'm going to subtract 2p squared, subtract 2p squared. So this is negative 1p squared plus 5 is equal to 4p minus 4p minus 4p. Negative 1p squared minus 4p plus 5 is equal to 0. A is equal to negative 1, b is equal to negative 4, c is equal to 5. B squared minus 4 times a times c. 16 plus 20 is 36. that's going to be 2 real, and because it is a perfect square, I also know that they are going to be rational solutions. So if I graphed this, they would actually be points. If you went the other way, so I had my p squared plus 5 is equal to 4p plus 2p squared. I'm going to subtract my p squareds. So that's going to be 5 is equal to 4p minus, or plus, excuse me, p squared, or 1p squared. I subtract 5, I end up with 0 is equal to 4p plus p squared minus 5. You can rewrite this, but I'm going to tell you that in this case, A would be 1, B would be 4, and C would be -5, okay, from writing it. But if you need it rewritten, you always go your squared term, then your plain x term, then your constant. And if I plug this into the discriminant, this is going to be b squared minus 4 times a times c. I still end up with 16 plus 20, which is 36, and you still end up with the same answer here. On the coordinate plane, draw a function whose discriminant is 24. So if the discriminant is positive, I know that it is going to intersect my axis in 2 spots. They're not going to be rational spots, but it's going to intersect in 2 spots. You could have something like this. You could have something like this, as long as it intersects in 2 places. Next thing is a discriminant of 0. A discriminant of 0 would mean that my graph, my quadratic, would intersect in exactly 1 spot. So right there, or maybe you'd have one that's like this right here. Number 6, so on the coordinate plane, discriminant is -53. Anything that you draw, as long as it didn't touch the axis or wasn't going to touch the axis, is fine, the x-axis. It could touch the y-axis, so this guy would actually work. Okay, it's just the x-axis that's the problem. An example of a discriminant with 1 real root, if it was, so for 1 real root, it would be actually 0. Okay. 2 real roots would be any positive. So if you wrote any positive number, and number 9, give an example of discriminant with 2 imaginary roots, this would be, sorry about this, this would be any negative number. So you could have written any negative number in that.